Okay, great, fantastic. I just told it to record and I have not even got my pen working yet. So we all know how that's gonna go. All right. Anybody? Anybody? What's happening here? Won't even let me switch the page. All right, so on 9A, there are 4 different strategies that we are going to learn today. These are all review. You did them in Algebra 2, I believe. The first strategy says if you have a single power of x, isolate that and then use a reciprocal power to solve. Okay, so Algebra 1 brain first. What can we do first on A? Divide by the 15. You have to do that first, guys. So we have x to the 2/3 equals 4. And then the second thing we need to do is to get rid of the 2/3 power. We can do both sides to what power? Yes, 3/2. Because over here, this would be 6/6. If we multiplied those exponents together, which would be just x to the first power. Now, what does this mean? Can someone remind me? 4 to the 3rd square rooted? Or the square root of 4 cubed? Doesn't matter which way we do it. Should have the same answer, which is, anybody? 8. So this is 2 to the 3rd, or 8. This is the square root of 64, which is also 8. And if you typed that back in, 15 times 8 to the 2/3, it would be exactly 60. All right, so can you do this one real quick? And feel free to just use 1/1.2 as your reciprocal. I don't care. I'm not going to judge. What? (1.2) is really 6/5. So you could do both sides to the 5/6. But like I said, it's not going to come out nice anyway, so you might as well just do both sides to the 1/1.2. Anybody have a decimal? Let's go out 3 places. Anybody getting something different? Kaden, is that what you got? Okay. Everybody agree in 631? All right. Is that the only 2 on that section, guys? Okay. Now, number 2 says, if a problem has a single exponential expression or a variable in the exponent, okay? So there's a variable in the exponent in one place. Isolate that exponential term, then take the log of both sides, and it doesn't matter whether you do the common log or the natural log, as long as you do the same one on both sides. But guys, you have to isolate first. So what do we have to do first here? You can't do 50 times 3, okay? You have to divide by 50 on both sides, yes. You have to isolate, meaning get alone, that exponential term. Okay? 1250 divided by 50, 25 maybe? How did I do? Okay? Now, anytime you have an x in the exponent, guys, hear me clearly. Anytime you have an x in the exponent, you're going to have to take the log. It's the only way to solve for an x in the exponent. Okay? So we've isolated it. Does anybody care? You want to do log or ln on both sides? Log, okay? So we have log of 3 to the 2x, we'll do ln on the next one, equals log of 25. Now, why did that help us? Yes, we can move this guy out front as a multiplication. Some of you got a little confused on that yesterday. Then what? Now all of this over here is multiplication. Yeah, we can divide. You can do it in one step, but you got to have some extra parentheses. I would probably just do it in two because I'm lazy. So if we take this side and we divide it by the log of 3, then we're still going to have to go back and do what? Divide by 2. But so whatever craziness we got there, we're going to divide it by 2. And the final answer, let's see, you do have to type the log twice. There's no shortcut. So it was log of, anybody, 25 divided by the log of 2? Did I remember right? 3? And then we had to divide it by 2, right? Okay. So 1.465, are we okay with that? Now, if I put 1.465 back in here, am I going to get out exactly 1250? No, it's going to be close. 50 times 2 to the, no, was it 3? This was a 3, and then there was a 2 up in the top, right? And this was 2 times, if we put in 1.465. No, it's as long as it's all in the box. What did I do wrong? That's not what we got. Okay, but I'm getting really close to the 1250, right? But I will tell you that the less places you use, the further away you'll get. So that's why I'm going out 3 places. Okay, moving on. So let's do one with what? An ln on both sides this time? Okay, so what do you want to do here? Divide by 6.6. So we have 0.5 to the x equals, I'm going to just leave that 0.8 over 6.6 because I'm super lazy. Then what are we going to do? You want to do ln this time? So we're going to do ln of 0.5, and I'm going to move that x out front, right? Equals ln of 0.8 over 6.6. So the last step is going to be to divide both sides by the ln of 0.5. So I get x equals I totally forgot. Was it 0.8 divided by 6.6 close parenthesis divided by the ln of 0.5? 3.044? Anybody? Okay, can you do the last one? Take your pick. Oh, wait a minute. Just kidding. What should we do on the last one? It'll work if you do log, but that just would confuse my little brain. ln of e will take care of itself, right? So let's just go through the steps real quick. If we divide first, I think it goes in nicely. Does it go in nicely? Yeah. E to the 0.5x equals 600. If it doesn't go in nicely, I would have probably just left it so that I didn't round yet. But now if I take the ln on both sides, I have ln e to the 0.5x, which I'm going to move out front. But what is ln of e, guys? You're going to save yourself a whole bunch of time if you know that ln of e is just 1. So all we're really left with is 0.5x equals ln of 600. So if we type ln of 600 divided by 0.5, we get x equals Anybody got an answer? Anybody disagreeing with 12.794? Okay. Feeling pretty good when there's an x in the exponent? As long as there was a single term? Okay. So just remember, you're going to isolate it and then take the log. Now, when you have a single logarithm, not an x in the exponent, but it has the word log somewhere, you want to isolate that, and then you're going to rewrite it as an exponent sentence, okay? Isolate and rewrite. Now, this log is all by itself already. What is the base? 10. So how are we going to rewrite this? Yes, 10 to the third equals 2x plus 20. That's 1,000. 980, did I subtract right? 490 if I divided right. Easy peasy. Okay. So basically what you're doing is you're looking at that problem and you're going, yeah, I have no idea how to solve that. So I'm going to rewrite it as an exponent sentence, okay? What's the trick to this one though? Yeah, we need to isolate the first before we try to rewrite it. Do you want to move that up there to a cubed? No. Let's not do that. Let's just divide it on both sides. So we have ln of x plus 2. If we divide both sides by 3, we get equals 2. Now what are we going to rewrite this as? What's the base? E, right? So it's e to the second equals x plus 2. So if you wanted an exact answer, it would be e squared minus 2. If you want an approximate answer, second ln with a 2 up here, and then a minus 2. Did I type that all right, guys? Anybody getting a 5.389? There's actually a question on the quiz that asks for both the exact and the approximate, but it starts out as a factoring question with ease. It's kind of miserable. We're not going to do that today. We're going to do that tomorrow for great fun, okay? But there is a question eventually where you do have to give exact and approximate. Martin, the throat drops are over underneath the plant, if you would like one. In the drawer that says batteries, I think is where I have them. If a problem has several log expressions, try to compact them. This is why we learned the properties of logs, okay? We want to compact them down to a single logarithm. And then we have two options, okay? We can do what's called exponentiate both sides up at the top, in the little drawers there. Or we can rewrite it. If it's a single log on one side, okay, then we're going to rewrite it. But if there's a log on both sides, we can do what's called exponentiate. Okay, so first of all, how do we combine plus into a single log? Multiply. So this becomes log of 2x times that other x equals 3. Now what? Well, I can simplify that to a 2x squared, but I have a single log, so what do I need to do? Rewrite it as 10 to the third equals 2x squared. This is 1,000, and what am I going to do to solve this? Divide by 2, be 500. And then I'm going to square root. Now we get to a little issue here. The square root of x squared should be a plus or minus. Which is, this is 100 times 5, so it would be 10 Square roots of 5 if I wanted an exact answer. Most of the time I don't care if you give me a decimal. But can we take the log of a negative number? No, you can't always throw away every negative, okay? If the question had said log of 3 minus x, could you put a negative number in there? Because then you're taking me log of a positive. So be careful, don't just throw away negatives from the get-go, but if I put a negative back in here, I'd have the log of negative square root of 500, and that's not going to work. So we do get to throw away the negative. So exact answer would be 10 square roots of 5. Anybody have an approximate answer for me? Square root of 500. 361. Thank you. All right. Anybody seeing that this next one looks a little different? Okay, because if I combine these, okay, first of all, what's going to happen when I combine those? If I move that 2, it'll become an x squared. Now, I could move things around side to side, but if I just leave it for a minute, what's going to happen here? What does minus mean? Yeah, so I'd have x squared over 3. Now, if the log of this equals the log of this, the only way that's true is if the thises are equal, right? So some teachers teach what you're basically doing is exponentiating each side so that these divide out. Honestly, it just makes sense to me that if the log of x squared over 3 equals the log of 12, then x squared over 3 has to equal 12. So if you multiply by 3, we get 36. We square root, we get plus or minus 6. Can we keep both of them? No, because this one right here just said ln of x when we started, and we can't take the log of a negative. So it's just going to be 6. All right, are there more of those? No, just mixed up altogether? All right, let's try this. Who's got this one? Destiny, you got the first one? What do we do first? Divide by 60. I don't know if that comes out nice. I might just leave it until later in the question. Oh, it is 5 halves? And then? Yes, because the x or t in this case is in the exponent, we need to do the log of both sides. Because it's an e, it would be much easier if we did ln on both sides. So I can bring the 0.02, oh no, it's just 0.2, right? That'll get me if I change the question here. 0.2 t down in front times ln of e, which is 1. So this is going to take care of itself. Yes, divide by 0.2. Ln of 2.5 or 5 halves divided by 0.2. Can I switch to log here all of a sudden? No. Make sure you type ln. What'd you get, Destiny? 4.581. Anybody agreeing? Brendan says yes. Okay, somebody besides Destiny's got the next one. Haley, what do I do first? Okay. Now, am I going to need the log of both sides, guys? When do we do the log of both sides? Yeah. I certainly could have done 70 divided by 4. It's not that bad of a decimal, but I just left it. What do we do when we have a funky exponent? This was strategy 1, maybe? No, because I'd still have the log of x. Can you look what strategy 1 was at the top of that notes sheet? Reciprocal, yeah. So what is the power we would need to do, Haley?
1 over.
Yeah. I don't know what that is. I'm not going to worry about it. I'm just going to type it on my calculator. 4.4 is really 4/10 or 2/5. So the reciprocal power is 5/2, 2.5, but I don't care. I'm just typing it in. 70 divided by 4, all to the 1 over 0.4 power, because I was too lazy to even do any work along the way. Did I type that right? 1 over 0.4? Is that what you got, guys? 1281.136. Yep, I cannot remember that, I'm sure, for long enough to write it down. 1281.136. I did. Okay. Number 3. Super easy if you remember the idea. Good job, Martin. Because plus turns into multiply. Okay. The only way that's true is if? Yeah. If 3x equals 48, divide and get x is 16. Good job. Brandon S., what do we want to do first on number 4? Algebra 1 first. What can we get rid of? Yeah, so we can divide both sides by 3. So then I have log of x over 2 equals 2. Now, I think it was the third strategy that said if we can isolate the log, what do we do then? Any ideas, Brandon? Or yeah, which means I write both. And some teachers will teach you to actually do the exponentiate and say they cancel each other out. I would prefer to just think of it as rewriting. How do I rewrite that? It is base 10, so it's 10 to the second. So 10 to the second and then times 2. Is it 200, guys? Okay. And that should work if we plug it back in, right? Exactly. Was that it on that page? Okay. If you switch over to 8A, apparently I don't have this in the right place. All right. We're on worksheet 8. I talked about this a second ago. Put that up again tomorrow. This is the bookwork for 3.4. The bookwork, first of all, your notes are wrong. I think it's not typed correctly. I don't think I managed to fix it, so every year it's wrong. It says at the top of your notes, for b is greater than 0 and b is not equal to 1, bx equals by if and only if x equals y. Do you see that? That is true, what it says, but it should say b to the x equals b to the y if and only if x equals y. So in other words, if I had something like this, the only way that's true is if I set the exponents equal. Everybody good? So if we can get a common base, then we can exponentiate or just look at the setting the exponents equal. So can we rewrite this with a common base? We could change those both to base 2, but can we just change this one to a 4? Anybody have a preference? You want to just leave this 4x to the x minus 1? What would this become? 4 squared to the x. Now what happens to those? Yes, they multiply together. So we have 4 to the x minus 1 equals 4 to the 2x. And then those bases are equal, so the exponents have to be equal. Let's see, if I subtract an x, I don't want to make a silly mistake. Is it just -1, guys? Okay. So if we plug it back in, we'd have 4 to the -2 equals 16 to the -1. This would be 1 over 4 squared equals 1/16. That's all looking true. All right. I am going to leave B for tomorrow because B is a miserable factoring question. So we're going to come back to that tomorrow, all right, guys? But let's practice a few more things today. We can do both of these. What are our strategies we learned? X is in the exponent. I gotta take the log of both sides. Do you want to do ln or log? Log. 3 to the x equals log of 19. This guy's going to move down front. You certainly wouldn't have to show every step here. But what am I going to do on my calculator at the end? Yep. Is this one done on your paper for you already? What's the crazy decimal? Okay, thank you. It does say nearest hundredth. All right. Again, exponents. But we're going to isolate this first. So we have e to the 8x plus 1 equals 7. Everybody good? There's an e, so I'm going to do ln of both sides and move the exponent out front. Now, it is a quantity, so don't lose that idea. But ln of e is just 1, so I just have 8x plus 1 equals whatever disgusting decimal this is. So if I type ln of 7, was that what it was, guys? I already forgot. And then that's equal to 8x plus 1. So like my directed studies kids would do, I can just do -1 and then divide it by 8 because they don't want to show work. Anybody getting that? Is that what it had on the worksheet? 0.12 to 2 places. This is a good one to maybe check. If I put it back in, I don't think I'm going to get exactly 1. What did it have? E to the 8 times, what did we get? 0.12? 0.12. And then plus 1. And then it had a minus on the back. And it was supposed to come out 1. I got 1.099. So not super close, right? 1.1? Yep. And it would have been better if we'd gone 3 places, would have been just a little more accurate, but it's all good. All right, so let's practice this. What can we do on these, guys? Yeah, we can turn them, well, and students will try this. They'll try to take the log of both sides. Because it has x's in the exponent. But if at all possible, okay, you don't want to have to mess with that because it gets real messy. What could we do? Because 3 and 9 are kind of related. Yeah, the 9 could become a 3 squared. So then we'd have what? This, which would become a 2x, equals this, which is just a 3x minus 4. Be careful, though. It's a quiz. That's the problem where I always show my work so I don't do something silly. I got positive 4. Is that working for anybody? Okay. Number 2 is a trick. Yeah, 4 squared is not 8. What are those both powers of? 2, yes. So this is 1 over 2 squared. And this one is 1 over 2 cubed. But what do we want to do with those? Somehow I need to make it the same. This is 2 to the what? Negative 2? That's what put it on the bottom. And then I have a 2x minus 1. And what is this one? 2 to the negative 3. And then I to the 11 minus x. Now does it look like powers almost? So this one is 2 to the negative 2 times 2x minus 1 equals 2 to the negative 3 times 11 minus x. So now, I know most of you would have jumped to that before here, but I'm trying to make sure the steps make sense. So now I can get rid of the bases and say negative 2 times 2x minus 1 equals negative 3 times 11 minus x. Did anybody want to leave them as 1/2 to the... You could have left them as 1/2. The fact that we did negatives, it wouldn't change our answer in the end. I hope someone's doing the algebra so they can check me. I got 35 equals 7x, so x equals 5. We could definitely go back and type it in the calculator if we wanted to, right? Maybe even we can do it in our head. 2 times 5 is 10. Minus 1 is 9. Yeah, this isn't sounding that fun, right? 1/4 to the 9th. How about we just stop now? Okay. I got 5. All right. Whoops. Can you try that one on your own? Make those powers of 2? Did I give it away? They should be powers of 2. What's this one as a power of 2, guys? Yeah, good job. Did anybody get 0.5 or 1/2? If you were real careful with your algebra, that's definitely one I could have messed up along the way. And anybody need to go back over algebra? Brandon S. got that. Uh-huh. Any questions? Either 1/2 or 0.5 is fine. I'm skipping 4 for today. Let's do a few more and be done. What about number 5? Can I make 9 and 12 both powers of the same thing? Nope. So what could I do? Yeah, I'm going to have to take the log of both sides. If I'm lazy and do ln, because it's less writing, this guy comes out front. And then what? Yeah, I gotta divide. And then eventually I gotta divide by 2. Whatever crazy business I got from that. What'd you get, Cameron? Kaden, did you type that one yet? Is that what you got? All right. We'll call it a day if we get through this one, guys. What are we going to do first on number 6? Got to isolate it first. Yep. Always think with your Algebra 1 brain first. Divide both sides by 2.4. Then we'll have to do ln to get rid of e, but 9.3 divided by 2.4. Does that come out nice, or should I leave it? Oh, okay. Well, it's not horrible, I guess. And then we're going to do ln of both sides. Bring the x minus 6 out in front. And what is ln of e? Yep. So that's just going to go away. And over here, whatever that mess was, you told me once, but I'm going to do what after I get it on my calculator? Add 6. ln of, I don't remember the numbers, Destiny. Oh, that was after you typed it in. And then it was 6. 7.355, maybe, if I round. All right. So, at the bare minimum tonight, guys, do the circled problems on 11B. Can you find that real quick? Because it's not hard. You could get half of them done now. Okay, at a bare minimum, finish the circled problems on 11B. If you want, you could also start working on these problems on page 196. Okay? Say that again. We did 5AB already. I hope you did. It's on finance. Did you maybe do it already? Yep. We are on this, so it is worksheet 11B, and feel free to start on the book problem on page 196, okay? So find 11B. See how many you can get done. Seriously, guys, we got 5 minutes left. I know you can get 5 problems done, probably, and there's only probably 10 on there, if that.